Start over. All right, so what I have here is, it is a bicycle, so rather than drawing all the parts of the bicycle, this is the front wheel, this is the rear wheel, this is the front sprocket, and this is the rear sprocket. Now what I mean by a sprocket is that's what the chain goes around. So the chain is going to go from there to there. Whoops. It's going to go from there to there, and then it's going to go from there to there. It's going to go around like that. Okay, so the chain's going to do that. Now the thing about a chain is that whatever the V is here, that's the V there, that's the V there, and that's the V there. The V is the same for all parts, but because they have different radii, they're not going to have the same angular velocity. So once I solve one thing, then I'll know the next thing. This is where your pedal would be, right? So you're going to be pedaling and making this thing move. The front wheel just moves because the back wheel moves. So there's nothing connected to the front wheel to make it move. It's like rear wheel drive on your bicycle, because this is making the rear wheel move, and there's nothing really making the front wheel move other than it has to move when the back wheel moves. So in this problem, I'm just going to write down my facts. So it says the front and rear sprockets have radii of 9 and 5.10 centimeters. I'm going to have those in meters. So I am going to say that R for the front sprocket, I'm going to write it this way. R front sprocket is going to equal 0.090 meters, because 9 centimeters would be 0.09 meters. And the rear sprocket is going to be, well, 5.10 centimeters would be 0.051 meters. So there's your front, your rear, your front sprocket radius and your rear sprocket radius. It says the angular speed of the front sprocket. So the angular speed of the front sprocket is 9.40 radians per second.
Part of the interruption is Nancy Lusigna. Please call group F14, Sam 14.
Now, the unknown, what they want to know is, what's the linear speed of the chain as it moves between the sprockets? So we want to know what that is. So if I know the V for the front sprocket, that is the V for the rear sprocket, and that's the V for the chain. So I can say that V for the chain is going to equal V for the front sprocket, and it's going to equal V for the rear sprocket. All of those are equal. The chain is going to move at the same speed as the chain as it goes around each sprocket. So you can see here that I have the radius for the rear sprocket and the angular velocity for the, I have the radius for the front sprocket and the angular velocity for the front sprocket. So I can use these two numbers to get the velocity of the front sprocket. And then I'll have the answer for the velocity of the chain. So that's going to be the velocity of the front sprocket is going to equal the radius of the front sprocket times the angular velocity of the front sprocket. So that's going to equal 0.090 meters times 9.40 radians per second. Now remember, this means, again, it's like a meter per radian. So the radians will cancel out. I am going to get my answer in meters per second when I solve this. And that came out to be 0.846. 0.846 meters per second. So there's your answer for part A, because if I know the velocity of the front sprocket, I know the velocity of the rear sprocket and the velocity of the chain. Now, the next part of the question says the centripetal acceleration of the chain as it passes around the rear sprocket. So I know the velocity of the rear sprocket, so I know the R. So if I want the centripetal acceleration, I can use those two numbers. So let me solve for something else that I don't have to solve for, but let's just solve it because we'll check our answer. Notice I don't have the angular velocity of the rear sprocket. So let's get that first. So the angular velocity of the rear sprocket is going to equal the velocity of the rear sprocket divided by the radius of the rear sprocket. So the velocity of the rear sprocket is the same as the velocity of the front sprocket. So that's going to be 0.846 meters per second. And I'm going to divide that by the radius of the rear sprocket, which is 0.051 meters. Now remember, that's like meter per radian. So I will get radians per second for my answer here. And what is 0.846 divided by 0.05? 0.051 divided by 0.051. Big number. 16.6. So now that I know both the angular velocity of the rear sprocket and the tangential velocity of the rear sprocket, I can use either one of these numbers to put this, doesn't look like an equal sign. I can use either one of these to get the centripetal acceleration. So I'm going to do both of them since I have both numbers there. So the centripetal acceleration of the, using v squared over r, is going to equal, I'm going to use that number, 0.846 meters per second squared divided by the what do I want to divide it by? Divided by centripetal acceleration in the chain as it passes around the rear sprocket. So the rear sprocket, I need to put that in here. So that's going to be 0.051 meters. And that should be the same answer that I get, what I would get if I put AC equals R omega squared. And if I put 0.051 meters times the omega was 16.6 radians per second squared, and I should get the same answer for both of these.
Yeah.
And what is that answer? 14.0?
14.0.
Oh, okay. All right, any questions on that? There's another problem similar to this. Actually, let me shut this off before I ramble on.